Welcome back. In this video, what we're going to do is we're going to explore the first derivative test. What the first derivative test is going to tell us where original function is going to be increasing, where it's going to be decreasing, where you might have maximum values, minimum values. What happens in this is that if the derivative is positive or greater than 0, then f is increasing on the interval. If the derivative is less than 0, then the original function is decreasing on the interval. So first of all, what we do is we identify our critical numbers. So we identify our potential turning points. So f prime of x is going to be 3x squared plus 2x minus 5. We're going to factor that. We're going to solve it. We have to get our critical numbers. So 3x and x. And I think we have this is plus 5 and this is minus 1. So then my critical numbers are at x equals negative 5/3 and x equals positive 1. Once we've identified those critical numbers, set up a number line chart. If we have any restrictions on our domain, I might indicate those on that number line chart, and I will do that over the next few videos. I'm going to put in my critical numbers at negative 5/3 and 1. And then I'm going to try my test values. I'm going to put my test values in, like if I choose a test value on this interval, first interval from negative infinity over to negative 5/3, say negative 2. When I plug in negative 2 in the derivative, I get a negative times a negative, which is positive. If I put in another one on this interval between negative 5/3 and 1, say I put in 0, I'm going to get a positive times a negative, which is negative. And then if I put in something beyond 1, say 2, I get a positive times a positive, which is positive. Now in this question, I'm only asking you where it's increasing. So it's increasing on these intervals on the outside. So it's increasing on the interval from negative infinity to negative 5/3. On the increasing and decreasing intervals, we include those endpoints. We'd never include infinity or negative infinity. And then this would be union with 1 to infinity. I didn't ask you for decreasing, but if I'd asked you for decreasing, it'd be on the interval from negative 5/3 over to 1. That will also help us in finding where things are maximum value or minimum value. If the derivative changes from being positive to being negative, then that's a max. If it changes from being negative to being positive, then that's a min. And if there's no change in sign at that critical number, then it's not a max or a min. If I go back to that first problem that I just did, I have those critical points at negative 5/3, and I had a critical point at 1. My number line looked like this, positive, negative, positive. So at this point right here, I'm increasing, then I'm decreasing, so that is a maximum value. So what we would say is there's a local max at x equals negative 5/3. You don't generally have to find the y value associated with that. At 1, I'm going to be decreasing and then I'm going to be increasing, so there's a local min there at x equals 1. Sometimes the derivatives, solving the derivatives, finding the derivatives can get more complex, so something like this with a fractional exponent. So the first thing I would do in this problem is I would distribute that x to the 1/3 and make it 8x to the 1/3 minus x to the 4/3. Then you're going to take the derivative, so f prime of x is going to be 8/3 x to the negative 2/3 minus 4/3 x to the 1/3. I'm going to rewrite that with this in the denominator, so it's going to be 8 over 3x to the 2/3 and then minus 4x to the 1/3 over 3. And then I want to write them with a common denominator. So the common denominator is 3x to the 2/3. The first part of that fraction, this part right here, I didn't have to multiply by anything, so that stays as being 8. That's still minus. I had multiplied this by x to the 2/3, so it's 4x. Now my critical numbers are going to be where the derivative is 0, which is where the numerator is 0. That happens at 2. And I also have a critical number where the derivative is undefined, which is at x equals 0. This equation is defined. The domain of this equation is all real numbers. So therefore, it is defined at 0, so I need to check both of those. So I set up my number line. I put in 0, I put in 2. When I go to put in my put in my test values, I don't have to worry about the denominator because this is squared. It's always going to be positive. So when I put in my test values, I just have to go to the numerator. So if I plug in -1, that's going to be positive. If I plug in 1, that's going to be positive. If I plug in 3, it's going to be negative. So then when I go to find my extrema of my function, here at 0, this is not an extrema because it's always increasing. It may flatten out or get a peak or something, but it's still increasing. And then at 2, we have this maximum value because we go from increasing to decreasing. So we have a local max at x equals 2 and no local min. Keeping on going, if we have g of x is equal to x to the 4th, and we want to know how many extrema I have, kind of the same idea as we just talked about. So g prime of x, find the derivative. It's going to be 4x cubed plus 12x squared. You're going to set this equal to 0 and solve it. So factor out a 4x squared. So 4x squared times x plus 3 equals 0. So when I do my critical values, it occurs at -3 and 0. Again, like my last problem, this part, this 4x squared part, this can never be negative. So when I put in my test values, I only have to worry about putting it in here, x plus 3. So if I plug in a -4, it's going to be negative. If I plug in a -2, it's going to be positive. And if I plug in 1, it's still going to be positive. So the only extreme I have is this one right here at -3, and that's a min. So only one local min at x equals -3. The 0 is not a max or a min. Sometimes you're given things like this where I'm given the derivative and I want to know where the function's increasing or decreasing, something like that. When I take a look at this rational function, when I look at this denominator, two things. Number one, it cannot equal 0, so you don't have to worry about that. The derivative is never going to be undefined. And then number two, it can never be negative because it's being squared. And this part can't be negative either. So the only critical number I possibly have is at 0. When I plug in my test values, I'm going to plug it in just in the numerator. So if I plug in like -1, this is going to be positive. When I plug in +1, it's going to be negative. And then based upon that, where is f decreasing? F is decreasing starting at 0, and it goes to infinity. Be careful about restrictions on domain, but again, in this case, this can never be 0 less than 0, so I don't have to worry about it. And then finally, a couple other things that we get into is sometimes they'll give you derivatives like this, like they'll give you a derivative like this, and they want you to focus on the first derivative test. And they're saying, okay, it's the sine of x squared minus 3, and we want to know where does f have a relative maximum between -3 and 3. You're going to put in your calculator. Okay, that's great. You're going to put in your calculator. What I did is I put this function in my calculator, and then I graphed it. It's just the top one that I have on right now. And then I graphed it, from -3 to 3, and it looks something like this. I'm going to have relative maximum values right here where the derivative changes from being positive above the x-axis to being negative below the x-axis. And then I have another one right here, again, where the derivative changed from being positive to being negative. So this is the derivative that I'm graphing. So when I look at that, when I calculate those values, I got x equals -1.732, and then x equals 2.474, something like that. And then finally, this is the other equation I had in my calculator. Again, this is a calculator equation. Let me kind of do this around. So what I'm going to do is I'm going to turn that one off. I'm going to turn that one on. And then when I go ahead and graph it, I'm going to graph it on the normal normal window from -10 to 10. Right here, I want to know, in this problem, what I want to know is I want to know where it's increasing. So I want to know where the derivative is positive. This is the derivative. Right here, it looks like it might get down to 0, and right here, it might get down to 0. So let's change our window a little bit. So let's zoom in. And when I zoom in on it, let me go, I'm just going to go from -1 up to 1. And I'm really going to zoom in on it. It doesn't come down and hit the x-axis there. Here, it has a horizontal asymptote on the x-axis, so it approaches it, but it never gets there. It's never going to get there. So in this problem, when I say where is it increasing, it's going to be increasing from -infinity to +infinity, or over all real numbers. Either way is okay for you to say that. This part right here is never going to get to 0. And the same thing here. This is going to converge to 0, but it's never going to quite get to 0. All right, so we'll clarify a little bit more in class, show you a little bit of AP examples. Good luck. This first derivative test stuff is big, important stuff, describing graphs over the next couple of days, next couple of videos in here. Good luck. See you soon.